it's me. I'm here to give you some help with homework 14. First of all, I just want to start out by telling you guys what you already know, which is that you are the most incredible students I have ever had the immense pleasure of teaching, and I'm so honored to be your teacher. This assignment, along with all the others, is very, very difficult. You guys are very much ahead of anyone that I know right now, and I'm so impressed. And so before you begin, just breathe. I know it's hard. It's supposed to be hard. It's physics. And just, relax. Make sure you have some chocolate nearby. See, I've got some chocolate nearby. You can't see it, but it's true. And we're going to do this together, okay? So problem number 1. Can you see that? I think so. Good. It says that a charge Q is traveling with velocity v through a uniform magnetic field of BZ. Okay, good. So notice, okay, here, this is a little bit convention that you need to know, okay? So it says V is 3 meters per second x hat. That means in the x direction, okay? So let's draw that, okay? So I'm actually going to change the numbers just for convention. So we'll make it V equals 5 meters per second x, okay? And we'll have the uniform, we'll have B, okay, is equal to BZ. Okay, good. So A, we want to know what is the direction of the resulting force on charge Q. Okay, now we're going to use that equation that we have, which is FB, the magnetic force, is going to equal Q times V cross B. Okay, now we're going to draw a little graph so that we know what our directions are. Okay, so this will be X, this will be Y, and X cross X, so if we have our hand in the direction of X, cross Y is Z, okay, which is up and down. We'll do that again. X cross Y is Z, okay? And that's just a good trick that you should know in general, by the way. So you should know that X cross Y equals Z, okay? Good. So that being said, let's find the direction of the force. Well, V is in the X direction, okay, so we have this is V. Okay, and B is in the Z direction, so this is B, okay? So we want V cross B, so here's V in the X direction like this. I don't know if you can see that. Make sure you're using your right hand like Shema Yisrael, and you cross in the B direction like this, and so your force is pushing downward. Let's do that again. So you're going to put your fingers of your right hand, like so, in the direction of V, whoop. Okay, and then I'm like, oh no, where's B, where's B, where's B, where's B, where's B? Oh, it's forward. So I this way, and my Z pushes down, my force pushes down. So V cross B, I'm gonna have the minus Y direction, okay? And you need to be able to do this cross product trick, okay? So B, if the magnetic field has strength B equals 10 Tesla, okay, 10 Tesla. We'll make it, actually, sorry, we're going to change this so that we're not actually giving the same answer. So we'll make it 10 Tesla, or make it, sorry, it says that. We'll make it 12 Tesla. Why not? Okay, 12 Tesla. Okay, Z. And the charge, we'll make it Q, we'll make it 3 coulombs. Okay. What's the force on charge Q? So remember, force is Q times V cross B, which is the same thing as QVB sine theta, where theta is the angle between V and B, okay? So since these are perpendicular to each other and we just found the direction using cross product, the sine theta is really just going to be 1, okay? Which means that really this is just going to equal QVB in the minus Y direction. Okay, I'm just going to repeat that to make sure that made sense. So we have cross product here, okay, which means that we use the right hand rule to find the direction that the resulting force is going to point in, right? But to find the magnitude, we have to use QVB sine theta. Now, in this case, theta is 90 degrees, and sine of 90 degrees equals 1, okay? Now, anytime you have a perpendicular situation, just know that it's just equal to QVB in the direction that you got from the cross product, okay? I know that's really confusing, but if you rewind that a couple times, you'll probably get it. And again, this video is not meant to watch through. It's meant to stop and rewind and figure out what makes sense, what doesn't, to yell at me for. And remember, if anything at any point confuses me, you email me, call me, text me, be like, Ms. Mizrachi, I don't get it. You are allowed and encouraged to do that, okay? Awesome. So this is gonna, now it's pretty easy. So this is just gonna be Q, which is 3 coulombs, times V, which is, what's the velocity? 5 meters per second we're using, times B, which is 12 Tesla, okay? And this is gonna equal 3 times 5 is 15, times 12 is, let's see, that's going to be like, I think it's 180, is that right? Yeah, it's 180. It's going to be 180 newtons. And if you plug in for each of, for these, if you plug in for the units, you'll find that it works out to newtons, okay? I'm not going to do that right now, but, you know, extra brownie points if you do it on your own. Okay, awesome. Now let's do part C. C said C. If allowed to move freely, the charge will exhibit circular motion. What is the centripetal force on charge Q? Okay, now this is a very interesting thing to think about. So really, okay, since B is in the Z direction, it's really more like a sheet, okay? And that sheet is going into the Z direction from everywhere. And it's a uniform field, okay? So this is really what our B looks like, okay? This is our B field. And this is the Z direction of force, right? This is Z, this is Y, and this is X, okay? Does that make sense? Not sure if you can see that so well. I think you can see it. Okay, good. So if I take a little charge, okay, and I want to let it go freely, okay? So remember my charge up here, right? It starts out going in the X direction. So this is the, let's say this is where my little charge is, charge Q. Hi, I'm charge Q. And I'm going to start going, this is my initial velocity, okay? What's going to happen is I have V cross B, which means the force we just said is going to be in the negative Y direction. So the force is going to be down this way. Excuse me, my phone. Sorry about that. So that means that, now think about it, if a ball is rolling straight and all of a sudden I give it a kick in a different direction, it's going to change its direction. So in this case, the charge won't actually change it won't change the magnitude of its velocity, but it will change the direction of its velocity. So over here, it's going straight like this, and then I'm going to kick it. So it's going to start going this way. Okay, so it's going to change its direction. So this, it's going to start being like, it's going to be like this, like la da 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 da. Oh, and it's going to crank this way. So this is velocity 1, and then it's going to start doing this, velocity 2, and then like this, right? So here, this is the force here, okay? So this is the force. Now it's going this way. Okay, fine. Now this way, we have V cross B. V, right? So here, I don't know if you could see it so well, but here, okay, let's pick up the paper. So it's like 3 dimensions, okay? So in this case, right, we have V going straight, and then cross B is outward, and so the force is down, okay? But now it's going in a different direction. It's no longer going straight this way. Now it's going at a slight angle. So instead, it's going this way, still perpendicular to B, cross B. Now the angle is going to be perpendicular to that. Does that make sense? So here, I'm going to make it a little bit bigger, okay? So what we have going on is here, this is the first velocity. And then, of course, the force is going to be perpendicular to it because the force has to be perpendicular to both the velocity and the magnetic field. Remember, that's what cross product is. So that means it's going to push to go a little bit this way, okay? Now that it's going this way, again, we need it to be perpendicular again, the force. So now it's going to be this way, the force. And now it's going to be a little bit this way. And then we're going to again have a force going this way. Because again, this cross this is that way. This cross this is that way. Does that make sense? So what's going to happen is you're going to end up with this kind of a thing. You're going to start out with your velocity going this way. And then it's going to curve. Okay? And then it's going to curve. And then it's going to curve. And then it's going to curve. And it's going to keep going all the way down because at each point there's a constant inward force. Do you see how that works? At each point, there's this force that's changing its direction. I mean, really, it's literally kicking it aside, but it's effectively doing with this centripetal force. Remember how I told you that, like, at each point you want to go straight and then it gets kicked? And that's how you have to think about centripetal force. Well, instead of doing it by pulling inward, this is doing it by kicking it from the outside, but it still has the same effect. And so what ends up happening, okay, is we have this circular motion with some radius r. So the way that you find out this is very confusing, I know, and I'm really sorry, I know I'm moving quickly, but if it's confusing, just rewind and listen to it again, okay? So my magnetic force then is going to equal my centripetal force, which means my magnetic force, right, which is going to be QVB, has to equal mv squared over r. I don't know if you remember this from a while ago. Now, just for now, take my word for it, but if we solve for the radius, we're going to get radius is mv over qb. And I encourage you to go on your own and just do the algebra yourself and see that this is true, but it is. And so that means that this is going to be, it says the mass of the charge is 2 kilograms, we'll just use that. So it's going to be 2 kilograms times the velocity, which isn't going to change in this case. And that velocity is, what do we say it was, 5 meters per second? Okay, divided by the charge, which is 3 coulombs, times the magnetic field, which is 12 Tesla. Okay, so we have, right, let's just solve this very quickly. We have 10 over 36 kilograms times meters per second over coulombs times Tesla. Okay, Coulomb Tesla are the same thing as kilograms per second, so you end up with just meters, which is exactly what we're looking for. And 10 divided by 36 is going to be around 0.278. Okay, but really you could also write it as 5 5/18, I think. Okay, that's the same thing. All right, good. Excellent. Again, if that's confusing, go back and watch it again. I know this is definitely, if not the hardest, certainly one of the hardest homeworks I've given you guys so far, but I have so much faith in you guys. I know you're going to do it and you're going to kick its tuchus. Okay, awesome. Number 2. If a charge q is traveling in the x direction with a velocity v sub x, if it travels through a uniform magnetic field B that points 30 degrees above the x-axis, what is the direction of the resulting force on Q? Okay, so let's say we have, so let's just draw it out, okay? So we've got, this will be, in this case we'll have this be y and this be x, okay? So our velocity is in the x direction, okay? And we have charge Q. And the magnetic field points 30 degrees above the x-axis, okay? So at this moment in time when it's right here, this is the direction of the B field. But remember, as I move it, so will the B field, because the B field actually looks something like this, because it actually has to circle around, okay? Because there's no such thing as magnetic monopole. But don't worry about that right now. Just know that this is true, okay? What's the direction of the resulting force on Q? Well, to do that, we just go V, take our fingers, point them in the direction of V, cross B, and point outward. Okay, so the resulting force is going to be pointing out in the z direction. Okay, so FB is in the plus z direction. Okay, good. Okay, and again, you should always know these steps. You put your fingers in the v direction and you curl into the b direction, and that's how you get cross product. Okay, so we want to know the force on Q in terms of Q, V, and B. That means I can leave the variables there. So the force, FB, is going to be QVB. And then remember I said it's times, well, we'll just do it this way. FB, okay, is equal to Q times V cross B, right? Which is the same thing as QVB sine theta, which is the same thing as QVB sine of 30 degrees. And I believe the sine of 30 degrees is 1/2. So this is your answer. Let me just double check on that and make sure it's true. I think so. Yes. Okay, excellent. So this is your answer, and then you're done. All right, now let me see how much time we've used. All right, I'm going to stop this here, And I'm going to use a new video to do part 3 because it's a little bit tricky. But up to this point, you guys are absolutely amazing. My loves, and I know you are going to learn this and be amazing at it, and I've got complete faith in you. And again, thank you so much for doing all this work. Pause, rewind. If anything here is confusing, get in touch with me, email me, message me, and I'm looking forward to talking to you guys. See you tomorrow.